Right, so now that we started recording, these were some of the problems that came from the Unit 4 discussion. So let me go ahead and work these out. Okay, this was, these problems were actually from the exam 4 review that had sample A and sample B and sample C. So I'm going to work these out first. And I also added some additional problems from these sample reviews. So let's look at the first one. Number 101 says, find the union and intersection of A and B. Okay. Let's find the union first. That means we're going to rewrite it like this. So the union means A or B. And know that A or B simply means we're just adding all the elements from A and then also including the elements from B. So A or B is going to be another set. So I'm going to grab all the A elements, 1, 2, 3, 5, 8. And now I'm looking at B, which is 2, 3, 5, 7. Well, I already have 2 right there. I already have 3 in the set. I already have 5. The only one I don't have is 7. I mean, if I want to, I don't have to, but I can put them in ascending order. So that's A or B. Now the intersection is just going to be common. This is like A plus B. So intersection is what do they have in common? And again, this would be, we would write it and represent it like that, equals another set. Now we're going to look at all the elements that are in A and in B. There's a 1, but there's no 1 in B, so we would not put that in the A intersection with B. 2 is in A, and so it's also in B, so we write that. 3 is in A, 3 is in B. 5 is in A, 5 is in B. And there are no other common terms. And that would be what we do with that one. Now let's look at 106. 106 says we're going to do an experiment consisting of rolling a 4-sided die and flipping a coin. A die with numbers 1 through 4, and a coin resulting either H for heads, T for tail. Now let's look at the space of the die. The space, because it's numbers, when you roll it, you're either going to get a 1, a 2, a 3, or a 4. The coin, the space for the coin is really just going to be heads or tails. So let's look at every single option here. Option A says we should get something like a 1 and a 3. Well, if I roll a die and then I toss a coin, the die says I should get a 1, 2, 3, or 4. Well, so this would not be an option because we need to get a result for this guy, comma, and then whatever the coin is. B says head or tails. Well, both of these blanks cannot be head or tail, only one, the coin. So obviously it's not that. C says, the coin can have a tail, and then the die can have a 1, definitely, because these are the members of each space for the die and the coin. So definitely C. And then D it says when you roll the die and toss the coin, you're going to get all these. Well, you don't get them all at once. So this definitely cannot be it either. And then 6 says E and H. H is okay, but definitely not 6 because the die only goes to only options are 1, 2, 3, and 4. So definitely not. So this would be your solution there. All right. The other question that students had in the Unit 4 discussion was number 201. So let's take a look at that. You're given a table, and we need to answer the following questions. N of B just means the number of in B, in the event B. So let's look at B. Well, here's B. So what we want to do is we want to go all the way down to the column that says total and grab that amount. So the number in B is just for event B is a total of 70. And then for B, we want the number of A and C, the intersection of A and C. So what we do is let me erase all this. We look at A, we go to C, here's C, and then go right where they intersect, right there, 10, total of 10. Now the next one is the number of B union with D. There's a formula that we can write that says B or D in this case would be the number of B plus the number of D, these events, B and D. But then we want to subtract the intersection of these two so we don't double count. So the number of B and D. So let's look at, we already figured out what the number of B is. So that would be give me a second. Sometimes this computer kind of locks up. So I just need to do something real quick. Okay, Raccoon? Are you there?
Yeah, sounds good.
Yeah, give me a second. I have to turn it off and turn it back on. Okay, let me just make sure that it's still recording. Yeah, still recording. I don't want to lose this. I have to post it in Canvas. Okay, so we said it was 70 for the number of B plus the number of D. Now we're looking at D, the number of D. Well, here's D. We go down to the total of D, which is 22. And now the intersection of B and D. Here's B and here's D. So the intersection now is 15. Well, that just means 92 minus 15. Which is equal to 77. All right. Let me know if you have any questions, okay? Are you good? Okay. Now I'm going to do number 122, which was another problem from the Unit 4 discussion. All right. So what we need to do here is we need to make a sign chart for g of x. G of x is a rational function. We have some polynomial divided by another polynomial. And then we're going to determine where g of x is greater or equal to 0. Okay. Before we answer this question, we have to do some pre-work, and that means this. Let's just make a couple of notes. G of x greater than 0 means when g of x is a positive number. Okay, so we want the left side of this or the inequality, the rational function to be pluses when we find out what the answer is. All right, well, the very first thing we want to do is find or actually I want to do this. Let's do this. We want to set the numerator equals to 0, so we can find where this g of x equals to 0. And that means x plus 3 squared x minus 5 equals to 0. And then we're going to solve for x. So we take the x plus 3. We're going to set each parenthesis equal to 0. If I take the square root of both sides, that means x plus 3 is simply 0. So that x equals to a negative 3. And then we do the same thing over here. X minus 5 equals to 0. X equals to 5. Now, the next thing we got to do before we set up our sign chart, we have to set the denominator equals to 0. That means x minus 2 to the third equals to 0. I take the cube root of each one, then I get x minus 2 equals to 0. X equals to 2. All right. So now we have these numbers. Note that when x is negative 3 or x equals to 5, g of x equals to 0. When x equals to 2, if I let x equals to 2, I'm going to get a 0 in the denominator, and that's what we did. So we're going to g of x is going to be undefined. Okay. Okay, now I'm going to move down a little bit here. Like I said, I'm going to post this in Canvas, so you'll be able to rewatch whatever you saw. If you didn't want to take any notes or anything right now, that'd be fine. Okay, so let me go here and let me keep those numbers there. I'm going to do this, and here's my my chart. Start out with negative 3. Here's negative 3. There's 0, and then there's x equals to 2 and x equals to 5. Now let's identify this. We said that when x is negative 3, g of x is 0. So negative 3, oh. I'm going to put a closed circle there. And I'll tell you why. Because the question was g of x greater or equal to. Has that little line right there. So it would be a closed circle. At 5, also a closed circle. And then at 2, I would get this open circle. So undefined, some 0 there, and some 0 there. Before I go any further, though, so these are your partition numbers. All these, x equals to negative 3, x equals to 5, and x equals to 2. What it does, the reason they're called partition numbers is because it partitions the entire number line into what? Into 1, 2, 3, 4 pieces. Now let's talk about what this interval is to the negative of, to the left of -3. This would be negative infinity all the way to -3. And then -3 all the way to this 2. But we put a parenthesis there. We put brackets here because of this greater or equal to at the -3. But at 2, because it's undefined, we put a parenthesis. So now here, give me a second again. The computer has also did it again. All right, let's see. There we go. Okay, so then the other interval is going to be 2 all the way to 5. 2 all the way to 5. And since that 5 is a 0, we put a bracket. And then the greater or equal to. And over here, we're looking at from 5 all the way to positive infinity. Now, I'm going to do this. Now, what we're looking for now to get the solution is we need to get some test points. To the left of -3 is -4 for my test point. Between -3 and 2, I'm going to use 0 as my test point. Between 2 and 5, I need a test point there. So the closest, smallest number is 3. So test point. To the right of 5, I need a test point because I need to do test points to the right and to the left of these zeros and all these partition numbers. So now what I'm looking at is I want to grab the function, which was what? X plus 3, x minus 5. Here's my test point, which is say net is x. But what I'm doing now is it keeps doing this. Okay, so now I'm going to grab and make sure it's still recording. Yeah. So now I'm going to grab the rational function, which is g. X plus 3 squared x minus 5 over x minus 2. I believe that was squared. And we're checking to see if this is, well, we're just checking to see if it's positive or negative. We want the positive, of course. And all my test points are these. I'm just going to do 1, but you know that that's what I'm doing. 0, 3, oh, yeah, 0, 3, -4, 0, 3, and 6. And I'm just substituting these values in. -4 plus 3 squared, -4 minus 5, everything over -4 minus 2 squared. I have put that in the calculator. I'm going to get a positive number here. So I'm going to label this positive. If I substitute a 0 into the function, I'm not going to go through all these calculations, but know that that's going to be a positive as well. And if I substitute a 3, then I'm going to get a negative. The computer keeps doing this to me. Let's All right, so G of 6 is positive as well. This was 0, 3, and 6. G of 3 was negative and positive. So my solution is going to be everywhere where G of X is positive, greater or equal to 0. G of X greater or equal to 0 on those intervals, meaning this one and that. Oh, I'm sorry. No, I wrote the wrong. This should be 2. Oh. Negative infinity. Yeah, negative infinity. Oh, this should be, yeah, that's negative 3. Negative infinity all the way to 2. Because all these are positive. And then I'm going to go union with 5 to infinity. And since these two and all these intervals, both of these intervals is positive, I can just combine those two and make it that. All right. Do you have any questions, Raccoon?
No, I'm following.
Okay. All right. I'm trying to go kind of slow so that I don't overwhelm you with. I hope I'm not. But do please let me know if you do have any questions. I don't want to.
Of course, thank you.
Yeah. Since you're the only one online. Okay, so there's that. Okay, so that's the end of that one. Let's go to the next one. Another problem from the unit for discussion. Here you're given P of A is 0.35. So the probability of event A is 0.35. So we're being asked to find the probability of A and C, which means the complement. Well, what we want to know is a basic fact that the probability of an event plus its complement has to equal to 1. So if we're given and these probabilities have to be less than or equal to 1, between 0 and 1. The probability of event A is 0.35 plus we're looking for the probability of the complement. In other words, not the complement of A. So then the probability of the complement of A is 1 minus 0.35, which is 0.65. All right, so the next problem that I have here, it's from sample exam A, exam 4 review. It says, which of the following sets is a subset of F? Okay. Well, a subset of F, so here's F with all the elements here. We're going to look at each one. A says, set A, it says 1, 2, 3. Well, F does not have a 1. So we know that it can't be A right away. It has a 2 and a 3. F has a, but it doesn't have a 1. So it cannot be a subset of F. These subsets have to, the elements of the subsets have to be, all have to be in F. Now B says, okay, well, there's a 2. So F has a 2. F has a 5 and F has a 13. So absolutely. Let me just circle it. So yes, this one, B is a subset of F because all its members are included in F. Now C, F has 2 but it doesn't have a 4, so it cannot be C. D, well, F has a 2 and F has a 13, so absolutely D would be another subset of F. Now E, F has 11, but no 12, and it does have a 13, so it cannot be E. All the members have to be in F. So B and D are subsets of F. Okay. Now, number 3, again, comes from sample A, review. Raymond is designing a t-shirt logo for his company. The t-shirt printing company offers 11 colors to choose from for the logo design. If any number of colors can be chosen, how many different color combinations are possible? Well, we can either choose or not choose. So we have 2 options, right? So 2 is how many options we have. You can either choose or not choose. But there are 11 colors. So 2 to the n, because n equals 11 colors, that'd be 2 to the 11. So if you put that in the calculator, there are 2,048 different color combinations. All right, let's go to the next one. Number 5. In a group of 65 people, there are 45 who have gluten-free, the event G, 35 who are vegetarian, the event V, 20 who are both gluten sensitive and vegetarian. Okay. So the number, because there are a group of 65 people, that's my total space. Gluten-free, the event is G, it's 45. The event V is vegetarian, 35, and 20 are both. So the number of gluten-free and V is 20. But what we really need to find is find the number of G, the complement of G, of gluten sensitive and vegetarian. What is that equal to? Well, let's do a Venn diagram, okay? That's what it says to do. But when we do a Venn diagram, it helps us to understand what we're doing here. All right, let me start out the Venn diagram. Okay, let's there we go. Okay, let's call this space here G and V. Let's focus on the intersection between G and V. That's 20. That means this intersection right there has to be 20. That's the intersection. This is G and V. Now, G says the number of G is 45. So this number would be 45 minus the intersection, which is 25. Now V is 35. So this would be 35 minus 20, which is 15. All right. Now, what we want to do is let's look at the complement of G. I'm going to shade. The complement of G just says not G. Not everything else, but not G. G is this big circle. Maybe I should have made it a different color, but I can do that. There we go. Okay. So not G is going to be blue. Well, not G means, okay, everything outside the green circle. Good enough. Now, that's not G. Now, V is actually this, the red circle. So I'm going to do this. That's V. So now back to answering the question. The number of not G and V will simply be wherever you see crosshatch, the blue and the purple. The blue and the purple says this. Oh, it's all the yellow. Well, all the yellow is simply what? 35 minus 20, which is just 15. The yellow shading. Any questions on that, Raccoon? Okay. All right, so that's number 5. Let's go to number 6. Number 6 says, a teacher has a matching section on a test. There are 5 total choices, but only 3 will be selected. That means if 3 are selected, you cannot, it's without repetition. How many ways can this be done? Okay. Let's write something. Okay, you have the first choice. You have the second choice. And then you have the third choice. Now for the first choice that you're going to make, you actually have 5 I guess answer choices. So 5, you can select from 5 different answer choice. And this is going to be a multiplication rule where we take 5. Now for the second choice that you make, now there's only 4 because we are not allowed to repeat it. Now we only have 4 choices to choose from times. The third choice, I only have 3 choices to answer choices to pick from. So if I multiply all these, I'm going to get 60 ways that this can be done. All right. Now, number 7 says, use the table below to answer the questions that follow. Find the probability of C. All right. The probability of C is just going to be the number of ways that C can happen divided by the number of the total space. Let's look at C. There's C. And if I go down to the total, well, then it's 32. And then what I'm looking at next is the actual total, which is the space. So divided by 100. I can just leave it like that, divide it whatever I want. Let me divide it and see what that number is. Should be 0.32. Or reduce the fraction. Now, the probability of the intersection of A and E is the number of ways that the intersection of A and E occur, also divided by the total space. Let's look at A and E. Here's A, and here's E. You come down to the intersection. That's 13. The total space is still 100. Okay. All right. Let me go to the next problem, number 8. Okay. It says a card. I put this card deck here just so that it gives us a visual of what we're looking at. A card is selected from a standard 52 card deck, which is showing on the here. Find the probability of getting a face and a card or heart. And a face card, of course, is a king, queen, or jack, meaning 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these guys. Okay, so let's write that in some form. We want the probability of getting a face card, or this is union, or face card, or let's put H for heart. So this is what we're looking for. All right. This is the probability of union. We can rewrite this as the probability of getting a face card plus the probability of getting a heart minus the intersection, because we don't want to double count. The probability of the intersection of a face card and a heart. So the probability of getting a face card is going to be the number of ways I can get a face card divided by the total space. And know that the total space is 52 because there are 52 cards. Plus the number of getting a heart divided by the space minus the number of ways I can get a face card and a heart divided by the space. Okay. The number of ways we can get a face card, again, I counted them. That was 12. The total number of cards, 52. The number of ways I could get a heart, let's look at the hearts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 hearts, 13 cards that have hearts. And 13, the space is still 52. Minus, this is where we do the intersection between a face and a heart. So which cards have a face and that are hearts? Well, hopefully you can see that it's these three. They're face cards and they're hearts. So 3 of them divided by the total space. And if you do that, put that in the calculator, you're going to get 22 over 52. Let me get a decimal for that. 0.42. Okay. All right, let's look at this next one, number 9. If the odds for an event E are 2 to 7, find the probability of the event occurring and the probability of the event not occurring. Okay. So what we want to know, write is that the probability of an event is the number of ways that the event can occur divided by the number of the total space. Now the total space is going to be the total number in the space is the number of ways of this event plus the number of ways of the complement. So, what we also want to know is that odds means the number of ways that the event can occur, colon, the number of ways that it doesn't occur, the complement. In this case, is 2 is given right here. That's the odds. 2 to 7. So the number of ways that the event E occurs is 2 plus the complement is 7. So it's 9, the total. So now coming back here, the number of ways that the event E can occur is the number of ways of E, which is 2 divided by the total space, which is 9. And that's your answer. Now the probability that this event does not occur is the complement, which is the number of ways that the complement occurs divided by the total space. Well, if 2 is a number of ways that E can occur, well, 7 would be the number of ways that the complement, that it doesn't occur, divided by 9. All right, moving on. Now let's look at number 19. A recent survey said that 56% of college students live on campus. So there's the event. Let me just write that in here. The probability that they live on campus. It's given by 0.56. Same thing as 0.56 divided by 100. The probability that they have a campus meal program. So the probability that they have a campus meal program is 62%, which is divided by 100 is 0.62. But the probability, and 42% that they do both, meaning that the probability of they live on campus and they have a campus meal program is 0.42. We need to check to see if these events are independent, disjoint, both independent and disjoint, or neither. Well, before we start choosing, let's figure out what that means. Let's just figure out. Let me check if events are disjoint. Disjoint means I have event OC and CM, and that they have nothing in common. There's no intersection. Now, we were given that the probability of OC and CM equals to 0.42. That means they do have some commonality and there's an intersection. In this disjoint visual, the probability of this event is 0. But we were given that it was 0.42, does not equal 0, therefore not disjoint. Definitely not that one. Neither independent, okay. Both independent and disjoint. We just said that it proved that it's not disjoint, so we would cross that out. And now let's go to B, which is going to check for independence. Check independence of these events to see if they even are independent. Okay. Well, one approach is this. I'll point out one approach that is actually a good one because of all the information of the data that was given here, or the probabilities. This is a very nice way to check independence. So let's do this one. The probability of living on campus, given that they get a campus meal, we have a formula for that. It's the probability of living on campus and campus meal divided by the probability of getting a campus meal. Let's see what that equals to. We have the intersection here, which is 0.42, divided by CM, probability is 0.62. All right. Now, this will give me a total of 0.6774. And we want to note to be independent, then the probability of on campus with a campus meal, given that you get a campus meal, has to be equal to the probability of living on campus. This has to check. Now, we just calculated the probability of on campus, given that it's you get a campus meal. And this does not equal to 0.56. This is the probability of living on campus. So because Let me, computer's acting up a bit. Give me a second. Okay. All right. So because it didn't check off what I wrote at the bottom to be independent, that's a fact, then we would conclude that the events are not independent. Therefore, not independent. And your answer would be D, because that says not independent as well as not disjoint, because we just proved that from the my computer. I need a new computer. Okay, so there it is. That's that one. Okay. All right. Now let's come to do another one here. Now we're on sample exam B. I'm going to do this problem and probably a couple or something. All right. So this is number 113 on sample exam B. Let's read through this. And it says, a company makes electronic gadgets. One out of every 50 gadgets is faulty. So right away, I can write something like this. Maybe I can just call it bad or defective or whatever you want, whatever word you want to use. Is or F, let's just say F for faulty. That's a little more F for faulty. 1 out of 50. But the company doesn't know which ones are faulty until a buyer complains. And then suppose the company makes a $3 profit on the sale of working gadgets, meaning good ones, but suffers a loss of $80 for every faulty one that they have to repair. Find the company's long-term expected profit. Okay. Well, before we can answer the question, we need to go back and figure and remember what the expected value means. We're basically just summing up everything over X, the X values times the probability of each X. So now I'm going to create a table that will help me answer this question. So I can multiply, add, and do all that good stuff I need to do. So first of all, let's go with X and the probability of X. It did say that, oh, by the way, the probability of F plus the probability of, let's just say good, a good gadget, probably of a good one, has to equal a 1. The probability of faulty was 1 over 50 plus what equals to 1? Well, we know that this must be 49 over 50 to make 1. So that's the probability of G. Now, every good one is $3 profit. So I would write, I get $3 for a good one. The probability of a good one is 49 over 50. And then we lose $80. So I'm going to put a minus, and the probability of losing of a faulty one is 1 over 50, as it was stated. Okay, so now that we have this, we're going to put the formula to work so that my expected value, I take the first X of $3, the probability of X, what we said is 49 over 50, plus you lose $80. The probability of a faulty one is 1 over 50. And if you were to just put that in the calculator, you get an expected value of $1.34 per item over a large number of cells. Okay. Okay, let's do another one. Some algebra here. Number 118. Okay. 118 says this. Which of the following is equivalent to this expression? All right. Well, before I can answer that, I'm going to take that and kind of simplify it, put it in a different form so we can choose the correct answer. Or there may be two answers. I'm not quite sure how many answers are. Let's see. I think there's well, let me do that first. We take 2x to the minus 4 over 7. This has a negative 4 over 7. That is the exponent. So right away, just by looking at some of the answers, we know that there's no way it can be that, because that has an exponent, a positive exponent. This one has a negative exponent. So we exclude that one right away. Now we're also going to exclude this one because that's also a positive exponent. And we know that that can't be the right answer. All right. Yeah, let's rewrite this. I can rewrite this as this. If I want this to have a positive exponent, I would take it and go, oh, well then 2. Only take that term back to the, and place that in the denominator. Not the 2, just the X term. All I did is took, if you can think of this as 1, I put the X term in the denominator with a positive exponent, because those are the rules of exponents. So I just did a simple reformat of this problem. And now let's see if there are any answers like that. Oh, look at that. There's one here. So obviously, yes, that's a good answer. But now let's take the exponent form and change it to a radical form. 2, I want you to know that A m over n in radical form is the same thing as n is the index and the m is the exponent of the base, which is the base is A. So in here, in this problem, we would say the 7th power, that's the index of x, the power is 4. Oh, this is good. So those two answers would be correct answers. All righty. All right, let me do a couple of more here that I have. The probability that it snows is, and the bus arrives late is 0.023. Let's say the probability of S is the probability that it snows something. The probability that it snows, this event S for snows, bus arrives late. Let's just call that L. There's a 40% chance of snow. 40 divided by 100, 0.4. So the probability that it snows is 0.4. Right. And the probability that it snows or and the bus arrives late, or either way, and is 0.023. I can write it like probability S and L or L and S, either way, and it's the same thing. So now what I want to find is the probability, what we're looking for, the probability that the bus will be late, so L, given that it snows. Okay, conditional probability, we need to find the formula for that. And the formula for this is going to be the probability of L and S divided by, this is the denominator, the probability that it will snow. And we are given this information, so it's simply just put in those numbers in there. The intersection is 0.023 divided by the probability that it snows, 0.4, giving us a result of 0.0575. Okay, I want to do this next one because it's a nice and short one, but it's a lot of verbiage. But then, so you know what all this verbiage just results in doing a simple calculation. I mean, a short calculation, let's put it that way. But it's kind of reading through all this that makes it some of these probability problems that may be a little challenging. Let's take a look at this. When we get to stop to a stoplight, it has to be either red, green, or yellow. I want to write these over here, rewrite them just for emphasis, but I'm going to call red, R, capital R. Points. The probability of it being red is 0.61. The probability of green, capital G, 0.35. And the probability of yellow, capital yellow, Y, equals 0.04. All right, now we have that. It says, you travel this intersection every day. What is the probability that the light will be yellow 2 days in a row when you arrive? What assumptions did you make? Well, the assumption that I want to make is that I'm going to assume independence, because these are 2 different days. So there's no way that these 2 events are going to be dependent. So assume independence. Independence. Or independent events or whatever. Okay. So now let's look at the first day. Okay, first day. The probability that the light will be yellow 2 days in a row. This will be, the first day will be the probability of yellow times the second day, different day. We wanted, what is the probability of yellow again? What is the probability of yellow? 0.04 times the probability of yellow again. So you get 0.0016. So it's really the probability of yellow to the second power, which is the same thing. If it had asked what is the probability that the light will be yellow 3 times in a row, it'd be just 0.04 to the third power. And then you just multiply it out. Let's see. Oh. Okay, that's that. Okay, well, I believe those are all the problems. Let's see.
I'm gonna. Any questions, Raccoon? You good? Are you there? Okay, I'm going to well, I believe that's all for today, Raccoon. I'm gonna go ahead and take this and stop the recording and post it in Canvas, okay?